Hello, geometry. Welcome to the first lesson of topic 5. Talking about some fancy relationships in triangles. This lesson 5.1 is on perpendicular and angle bisectors. So again, we've talked about these. We did these constructions back in topic 1, right? The one thing they have in common is this word bisector. Remember, when you bisect something, you split it into two congruent parts. So we just got done with the chapter, the topic on congruence. So I think that might play a role here. So keep that in mind as we go through these bisectors in triangles. All right, so example 1, it says, how can you find points that are equidistant from the endpoints of segment AB? And what do you notice about these points? So a point that is the same distance from 2 points is what we call equidistant. So same distance is equidistant. So if you recall here, we did a construction in Delta Math, if you remember, and it was called the perpendicular bisector. So I'm not going to go through and do it again, right? But I'm going to talk about how you would do it. So if you remember, you would take a segment, you'd open up your compass more than halfway. So here's halfway, go more than halfway, and you make an arc above and an arc below. So what this is really doing is it's creating a segment here, right? That's the same distance from A. Okay? All right. And then we would keep the same compass setting, so the same length, and we create an arc above and below from B. And again, what it's doing is, and it's creating points that are the same distance away. And then these 2 points, right? I'll draw these 2 points, we would connect. Right, I fudged it a little bit to make it look right. And this would be the perpendicular bisector. But in all reality, right, what we did was we created 2 points above and below that are all the same distance away from A and B. Right? Now we could do the same thing if we made our compass a little bit bigger, right? So say it was a little bit bigger, it would have been up here and down here, and then put it on B up here and down here. But again, these points would be the same distance away, and so would these points. So what I'm getting at is that, what do I notice about these points in the relationship? These points appear to be on the perpendicular bisector of segment AB, right? So the points appear to be on the perpendicular bisector of segment AB. Again, that upside down T means perpendicular, right? I use shorthand to try to get you guys to, write faster and remember the symbols. Okay, so hopefully that made sense. So I think we're going to talk about 2 theorems: the theorem, the conditional, and its converse in regards to the perpendicular bisector. All right, so it says the perpendicular bisector theorem. What a name, right? Perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So if the point is on the perpendicular bisector, then it's equidistant from its endpoints. So again, up here, we are being told that L is the perpendicular bisector of segment XY. So therefore, the distance that P is from X is the same as the distance that P is from Y. Now the converse is also true. So this is the converse. So again, now you say if the point is equidistant from two endpoints of a segment, then it must lie on the perpendicular bisector. This is actually quite powerful, right? Because saying that something is the perpendicular bisector is again giving you a lot of information. So in this picture here, you're being told that P to X is the same as P to Y. Well, therefore, that means that PQ, or line L, is perpendicular to XY, and it bisects XY, just like what it says here. All right, so let's prove the theorem. Right? Love to prove things. So here we go. Here's our picture. We're going to prove the perpendicular bisector theorem. So it says, given that L is the perpendicular bisector of segment XY, prove that PX equals PY. I'm going to do it in a paragraph proof. Okay? So we're going to say since we are given that L is the perpendicular bisector of segment XY. Then, well, we're going to handle both parts, the bisector part first. Then we know that XQ is congruent to YQ. Then segment XQ is congruent to segment YQ. And angle PQX and angle PQY are right angles. And this is by the definition of a perpendicular bisector. Bisector. Sorry about that. The R. So we have two right angles, and we have a pair of congruent sides. Now I hope you can see, and from topic 4, that we're going to try to prove that these two triangles are congruent. That's our goal, right? So I know that I have one pair of sides, side 1. Now I can say that these two triangles are right triangles and try to use HL using XQ as a leg, but then I would have to be able to prove that PX is congruent to PY. Well, that's what I'm trying to prove. I can't use it. So we're not going to use HL. So we're going to use one of the other ones. So then I should say that these two right angles are congruent. Okay? So that's my next step. So since all right angles are congruent, angle PQX is congruent to angle PQY. So that gives me a pair of angles. So there's angle 1. And now if you notice how these two triangles touch, they share PQ. PQ is going to be congruent to itself, and that'll be side 2. And these two triangles will be congruent by side, angle, side. PX and PY are corresponding parts, so they'll be congruent and their lengths will be equal. And that's the proof, right? So now I'm going to say the PQ part. So by the reflexive property, segment PQ is congruent to itself. Therefore, triangle, and I just called it PQX, just like I named the right angles. Triangle PQX is congruent to triangle PQY by side angle side congruence. So then by CPCTC, segment PX is congruent to segment PY. And if two segments are congruent, then their lengths are equal. Thus, I always like to use thus for my last sentence. Thus, I feel like, special. Thus, PX equals PY by the definition of congruent segments. And there we go. That's a check mark for a job well done. It's a pretty common proof, right? Proving the perpendicular bisector theorem. Excellent. Okay, so I got one more problem in this video, and then we'll stop and we'll move on to angle bisectors, potentially. All right, so this one says Mr. Lee wants to park his ice cream cart on Main Street so that he is equidistant from the entrances of the amusement park and the zoo. Where should Mr. Lee park? How can he determine where to park? So he wants to park on Main Street. So he's got to be on Main Street somewhere, right? But he wants to be equidistant from the entrances to the amusement park and the zoo, right? So if we look here, I'm going to make this dot the entrance to the zoo and this dot the entrance to the amusement park. So this is an application of the perpendicular bisector theorem, right? We need to find the perpendicular bisector between the zoo entrance and the park entrance. So I'm going to make this a segment. So basically what we're going to do is we're going to find the intersection of the perpendicular bisector between Zoo and Park and Main Street. So we're going to find the intersection of the perpendicular bisector between the Zoo and the Park and Main Street. So here is your segment connecting the Zoo and the Park entrance. So again, identify where you think the midpoint is. I'm going to use purple. I think it's right around here. So again, this should be congruent to that. And then just go perpendicular. And again, I'm just fudging it, right? But it's hard with this tablet to draw diagonally. I apologize. So I'll do my best here. Let me go. Oh, there we go. Perfect. Right? And that to me looks perpendicular. So I'm looking for the point where the ice cream, or I'm sorry, where this perpendicular bisector hits Main Street. So again, I think if I was him, I'd want to park on the same side, right? So I think I'm going to be right there, right? So that would be the point where my ice cream cart goes. Right there. And again, for this reason up here, and if I do try to connect it to the park entrance and the zoo entrance, these two lengths should be about the same because this cart is on the perpendicular bisector between the two entrances. Great. Okay, second video is coming up next.